All right, this is it. 12-2. We're just doing it in one shot. It's about tests about a proportion. All right. You don't have to worry about t-tables. We get to do z's every single time. You choose a simple random sample from a large population, right? That randomness is an important condition. And we're always testing, does the proportion, the true proportion, equal the claimed proportion? And so we take our p hat minus the claim, and we want to use the claim and 1 minus the claim over n inside the square root to get our, that's our standard error, okay? And we use the claim, not our p hats, because then everyone's using the same measuring stick as opposed to us using p hats in here, which has varying measuring sticks, okay? So we get z. It has a normal distribution for large samples, okay? That's the large counts that we're going to talk about right here. And p and nq are both at least 10, all right? And we're wondering, probability, if the alternative is greater, we're looking to the probability to the right. If the alternative is less, we're looking probability to the left. And if the probability, the proportion is not equal, we're looking for the sum of the probabilities on both sides, okay? And we're going to use phantoms again. So hopefully you're getting used to using phantoms, and this will be nothing surprising. So here's, according to the National Institute for Occupational Safety and Health, job stress poses a major threat to the health of American workers. We have a national survey of restaurant employees. 75% said that work stress had a negative effect on their personal lives, right? So you can see the null is that rho would equal 0.75, okay? The parameter now we can see is that rho equals the true proportion of restaurant employees. Well, we're looking at this large restaurant chain, okay? Large restaurant chain. We're wondering, is this restaurant chain have the same data that the national survey? Does it agree? Okay. Have stress, okay? That affects their work life. Something like that, all right? The alternative, is this good reason to think that the proportion of all employees in this chain who would say yes differs from, so not is greater than or less than, it's that the rho for this in this chain is not equal to 0.75, okay? Assumptions and conditions, random, independent, and normal, okay? A random sample, it's a large restaurant, and so as long as there are at least 1,000, okay, is the 100 employees less than 10% of all employees, reasonable to assume that they have 1,000 employees if it's a large restaurant chain, okay? And then normal, well, NP is 100 times 0.75, which is 75, and N times 1 minus P is 100 times 0.25 is 25, okay? They're both at least 10, and so large counts, ish, okay? All right, and then we can proceed, all right? So once again, calculator is the place to go. You can look up, if you calculate the z-score, you can go to a z-table and get a very close to 3 decimal places p-value or 4 decimal places, but I still like the calculator because if you go stat, calc, you can do, tests, you can do a 1 proportion z test. So number 5 right here, the claim is 0.75. We had 68 out of 100, and we're wondering the probability that it is not equal. And we calculate, and we get this. So there it is. My z is negative 1.62, my p-value 0.106, and there's my p hat and my sample size, okay? So name the test. It's a 1 sample z-test for proportions, okay? Test statistic is z equals negative 1.62. My p-value is 0.106, and my decision, since my p equals 0.106 is greater than my alpha, which I forgot to mention, 0.05, which is alpha, we fail to reject the null, okay? And then there is insufficient evidence to conclude this restaurant chain has different than 75% stressed, or employees stressed out. Okay. So anyhow, make a decision, state inclusion, and you are good to go. So that's the flow of a hypothesis test. So we've done a z-test you're almost never going to see, but a t-test, and then a one prop z-test. All right. So next chapter we'll get into a two sample z-test, and we'll be able to really start finalizing all of our inference. So good luck and farewell.